Hello and welcome. Today, we're going to crack the code on a really powerful statistical method called survival analysis. It's the tool researchers use to answer one of the most critical questions out there. Not just if something works, but how long it works for. So let's dive right in.
So often, we start with what seems like a simple question. Hey, does this treatment work? But a yes or no just doesn't tell the whole story, does it? Survival analysis is all about asking the real question, the one that actually matters to everyone, from patients to engineers. How long does the benefit really last? And that brings us to our very first big idea. If you want to get a good answer, you've got to start by asking the right question. So let's really break down what that real question looks like. Okay, so here's the crucial shift in thinking. We're moving beyond a simple yes or no checkbox. Instead, we're measuring duration, the time until something happens. Maybe that something is a patient relapsing, or maybe it's a machine part failing. This is what we call time to event data, and it's so powerful because it captures the whole journey, not just the final destination. So, you might be wondering, why can't we just use our usual statistical tools, like a t-test, to compare the average time between two groups? I mean, it seems simple enough, right? Well, it turns out, with this kind of data, those familiar tools totally, completely break down. Let's look at why. This slide really lays it all out, doesn't it? On one side, you've got the super clean, ideal world of standard stats. Everything fits a perfect bell curve, and we have all the data points. But then, there's reality. That's the other side. People drop out of studies, the study itself has to end, and the data is almost always lopsided, or what we call skewed. It's just messy. And this messiness leads to two huge practical problems for researchers. First, there's the follow-up gap. I mean, life happens. People move, they decide to stop participating. You just lose track of them. And second, there's the waiting game. If the event you're studying is, say, a natural death, you could be waiting 50 years to get all your data. That's just not going to work. And I love this analogy because it just hits the nail on the head. If we just toss out the data from people who leave a study early, our results get seriously biased. It's like you're trying to review a whole movie, but you only watch the first 20 minutes. Of course, your conclusion is going to be wrong. So how do we fix this? How do we deal with this messy, incomplete, but incredibly important data? Well, this is where a very special set of tools comes in, the Survival Analysis Toolkit. Let's open it up and see what's inside. In this toolkit, we've got two main instruments. First up is the survival function. Think of this as the optimistic, glass-half-full perspective. It answers the question, what's the chance of making it past a certain point in time? Then you have the hazard function. This is more of the immediate risk view. It asks, okay, you've made it this far, what's the risk of the event happening, like, right now? But here's the thing. Both of those functions, the survival and the hazard, they only work because of one single ingenious idea. It's the absolute key that unlocks everything. But it can also be kind of confusing at first. So let's solve the mystery of censoring together. All right, so here's that dilemma again. Imagine a patient is in your trial for 3 years, and they're doing awesome, no problems. Then, poof, they're gone. What do you do with those 3 years of really good data? You can't just hit the delete button, right? That information is pure gold. The answer is a technique called right censoring, and the core idea is just beautiful in its simplicity. We just acknowledge that for this person, the event we're watching for has not yet happened. We don't get to read their final chapter, but we do know their story up to a certain point. Our observation of them has ended, but their story hasn't. Let's make this super concrete. So a patient joins a trial. For 3 solid years, they are event-free, which is great news. But then they have to move to another country. We can't follow them anymore. With censoring, we don't throw away their data. No way. We include those 3 event-free years in our analysis. We count it as 3 years of survival. And then we just make a note that that's where our observation ended. And that's the bottom line. Censoring is what lets us use every single piece of information we can get our hands on. It honors the contribution of every single person in the study, even if we don't know how their story ends. It makes our analysis not just stronger, but way more true to reality. So why have we spent all this time talking about skewed data and censoring? Because this method has a massive impact. It's used across so many different fields. Let's just take a look at how far its influence really reaches.
You know, if you've ever read a medical study, you've probably seen a Kaplan-Meier curve. It's that famous graph, the one with the descending steps showing the percentage of a group still surviving over time. Well, censoring is the hidden engine that makes those incredibly powerful curves even possible.
And the applications are just everywhere. In oncology, it's the gold standard for comparing how long a new drug, for example, can keep a tumor from growing.
But what's so cool is that the exact same math, the exact same logic applies in totally different worlds, like engineering. You can use it to predict the lifespan of a critical part in something like a jet engine. And yep, it's even used all the time in business. Companies use it to analyze customer churn. That is, predicting how long you'll probably stay subscribed to a service before you cancel. So you've got medicine, engineering, business. It's all survival analysis.
So let's end with this one thought to chew on. We usually think that all the good stuff, all the real answers, only come at the very end of the story. But survival analysis, with its clever idea of censoring, teaches us something kind of profound. Sometimes the most valuable, most powerful information we have comes from the stories that are still being written.